So remember that the square is a number multiplied by itself. We're going to keep going through what's the square of 10? That's written as 10 squared. And that squared means that it's 10 multiplied by itself twice. So it's 10 times 10, which is 100. So far, no big surprises. What is the square of 9? So we write 9 as 9 squared. And 9 squared is like 9 times 9, which is 81. Now, squares are super helpful in a lot of things. It's useful mainly in finding the area of a square. So if we know that we've got a pen for our llamas and it's 4 meters by 4 meters, how much area do they have? You know, this is also something that you'll use to figure out the square foot, how big your house is in square feet. They do this exact sort of measurement. If the room is square, you can take one side and you can square it. So 4 squared, or 4 times 4, is equal to 16. If you counted each of these square meters, you'd get 16 of them. Same as this one, if you drew out a 10 by 10, you would have 10 on one side, 10 on the other, but there would be 100 squares in the middle. All right. The opposite of a square is called a square root. And don't let this freak you out. The square root sign is one of these things. We don't write anything in here if we have a square root, but essentially this is what I'm just going to write this in here. This is a square root. So we're saying, when asked what the square root of 9 is, you know, the square root of 9, what we're really asking is what two identical numbers multiply to make the square root. So what two numbers multiply to make 9? So the square root of 9 is the same thing as really it's like the same thing as saying 3 times 3. I'm just going to add one more person. The square root of 3 times 3. What I do is, when you have a square root, you can take a pair of numbers and you can pull them out of the square root and they just turn into one of those numbers. So it's 3. And we can go backwards, and I'll show you that in a few minutes here. So again, if it says, what's the square root of 49? So we're asking ourselves, what are the two identical numbers that multiply to give us 49? Well, I know that 7 times 7 is 49. So I have 7 times 7. And I haven't changed this at all. I've just changed 49 into 7 times 7. I haven't done anything to it. I just rewrote it in a different way. And if we're doing a square root, we're looking for pairs of numbers. I've got a pair of numbers, so I can pull that out of this square root, and that just becomes one of those numbers, 7. So far, so good. You can even test this on a calculator as well. You can do the square root of 49, and we're going to do that in just a moment, because using a calculator here is really important, not necessarily for these ones, but here in about 3 minutes, they're going to be important again. All right, let's do the square root of 25. So again, we're asking ourselves, what two numbers, identical numbers, multiply to make 25? Well, I think that it's going to be 5 times 5. And 5 times 5 is 25. Because I have a pair, I'm going to circle the pair, and I'm going to be able to pull them out of the square root, and it just becomes one of those two numbers, 5. And last but not least, square root of 100 is the same thing as square root of 10 times 10, because those are the two identical numbers that make 100. Because I've got a pair, I'm going to circle those. I'm going to pull them out of that square root, and it just becomes one of these pairs, which is 10. Now this is really deadly useful again for figuring out area, but say we have a room that's 144 square feet. How long are the walls? Well, we can do, what is the square root of 144? Well, I know that 144 is like 12 times 12. Those are the two identical numbers that multiply to make 144. I'm going to circle that pair, pull them out of the square root, and it'll just become one of those numbers. All right. Here we go. Another way to think of a square root is to ask, if the area of a square is 9, what are the sides? So if the area is 9, you've counted these 9, there's 9 of these squares. how long are each side? And you take out the square root of 9 is equal to the square root of 3 times 3. There's our pair, so we're going to pull them out, and we got 3. So far, no big revelations here. And this is where they're going to start getting a bit more interesting here. So what happens when we ask for the square root of 10? So let's think about the rule. The square root means what two identical numbers multiply to make 10? Well, I know 2 times 2 is 4, so that doesn't count. 3 times 3 is 9. That isn't 10 exactly. 4 times 4 is 16. Hey, wait a second. 10 got missed out there. And what's the deal with this? Well, of course, we know that there's not two whole numbers that don't multiply. There are no two whole numbers that multiply to make 10. So we know it's going to be somewhere between 3 and 4. So again, we've done this. We had 9 to 16. 10 is missing. It's not a perfect square. A perfect square always has to have whole numbers. So a perfect square has sides that are not, a non-perfect square have sides that are not whole numbers. So it's like a point something or a point something. Same number again. 3.2 times 3.2 does equal 10, roughly. So again, I'm going to get you guys to grab your calculator. I'm going to try this. Each calculator is slightly different, so you're going to have to figure this out for your own calculator. Maybe you have to hit the square root and then 10 and then the equals. Maybe you have to do 10 and then the square root, and it just pops up with the answer. I'm not exactly sure, and this is going to be dependent on your calculator and which one you use, but just get to know or understand how your calculator works, because we're going to be using this button quite a bit here. So if I do the square root of 10, it gives me 3.16 and probably a whole bunch of other numbers. And this is a really close approximation to the exact answer. 3.16 times 3.16 is going to give me something close to. Let's see what it does. Just let me bring up my calculator here. 3.16 times 3.16 gives me 9.9856. So it's pretty darn close. If I do the square root of 10, that's an even closer one, but it's not exact either, but this is pretty darn close. But for this example, this is exactly what we're looking for. 3.16 or 3.2. Sometimes that's close enough. All right, so here's your job is, can you find the square root of 42? Well, the first thing I'm going to do is I'm going to try some of my multiplications. So 6 times 6 is 36. Well, that's a little lower than 42, but not quite. And 7 times 7 is 49. 42 is right between 36 and 49. So it's going to be in between somewhere. And I'm not sure where. So this is where you're going to grab your calculator. And, oops, I'm covering up this. And I'm going to do 42, and then the square root gives me 6.4807, and it keeps going. I'm going to just say 6.5. And that's going to be perfect for here. So in calc, square root of 42 equals 6.5. I hope that makes sense to everyone. Oh, I've got more people. Again, I apologize that I haven't added people. It's way over on this other screen. So those of you who are just joining me, I'm apologizing for not letting you in sooner. I'm just getting all geeky about math here. Don't worry. Again, the other thing that I want to show you, maybe this is a perfect time to do it, is for instance, let me just go back to the modules here. If you do miss a section, I'm going to go to last week's thing. There's the notes. And if you didn't get enough excitement watching me talk for an hour, you can also watch the YouTube video. It's the same thing, it's just me recording the Zoom video. So you can watch me do the examples again. The other thing that I want you guys to do, and this is all in Canvas again, is if you keep scrolling all the way to the very bottom, hey, and the notes answer key is right here. So if I go into the answer key, it's going to have all the notes, hopefully, and the answers in there so that you can check and make sure that you're doing it right in case you missed out. All right, let's get rid of that. Let's go right back to the, let's go back to our examples here. So how about the square root of 99? So you guys have probably already done this. Square root of 99 in a calculator. Let's do that here again. I know 9 times 9 is 81, and 10 times 10 is 100, which is really close. So it's going to be really close to 10. It's probably going to be like 9.9. And let's see, 99, 9.95. All right, that was pretty close. 95, something like that. Okay, I'm going to move on to page number 2, because I always take way too long at the start, never leave enough time for the end. Okay, do I have color? I do, yay. Okay, so if you don't have a calculator, there is a way of sort of approximating or getting a rough answer. And I'm going to show you how to do this. There's going to be one question on the test very similar to this, so there's your warning for you. What's the square root of 20? So the step 1 is I'm going to find the perfect squares above and below. Perfect squares, remember, are whole numbers. So what are 2 whole numbers? Well, 4 times 4 is 16. That's a whole number. 4 times 4, that's too low. And 5 times 5 is 25, and it's too high. And that's perfect. That's what we want to do as the first step. Step number 2 is we're going to draw a number line and put in our perfect squares. So I'm going to say, okay, the square root of 16 is going to be 4 here. And the square root of 25 here is 5. I've just figured these out, right? Now, if this was 16 and this was 25, where is 20? It's somewhere around here, I'm guessing, a little closer to this one than this one. There's 4 and there's 5 here, so it's a little bit on this side of half. And then you can estimate where it is. So between 4 and 5, this is going to be the square root of 20. We're going to go on the number side, not on the square root side. This is going to be around 4.5, something like that. 4.45, I'm not exactly sure. So the square root of 20 is 4.5. Let's see how we did on our guess. I'm just doing this to double check. Square root of 20, 4.47. There you go. So again, pretty darn close. 4.47 rounds up to 4.5. And that's how you could just guesstimate. You can make an estimate about how to get close to a square root of a non-perfect square without using a calculator. All right, so let's do this one. You guys, this is your turn to step up and see if you can do this. What's the square root of 30? So you guys remember what step 1 is? All right, so step 1 is I'm going to try to guess the perfect squares above and below 30. If I do 5 times 5, that's going to give me 25. So I can say the square root of 25 is equal to 5. And 6 times 6 is 36, which is above. So the square root of 36 is the square root of 6 times 6. I'm going to take one of those pairs when I pull it out, so this is 6. So knowing that the square root of 25 is 5 and the square root of 36 is 6, I can just draw that in here. It doesn't matter if it's on the top or the bottom. Which of these? That's going to be 5. This is going to be 6. Where does my square root of 30 fit? Oh, somewhere pretty close to the middle again. I'm just going to say there. You could be super geeky about it, but I'm not too worried about it, which is going to be about 5.5. Again, based on 5, this is 6, so that lands somewhere about in the middle. And let's pull up the calculator one more time just to double check. Again, sorry that I'm not picking up on people joining the room yet. Okay, and we've got 30. Let's find the square root. It's 5.5. And we got it just right. Perfect. Okay, take a breather for a second. Nice deep breath. We're going to get into a little bit more complicated, but again, it's not so bad. Just one other little way of doing this. So calculators get really close, but not perfect. Because if I multiply 5.5 times 5.5 gives me 30.25. It's not exactly 30. It's close, but it's not exactly. And sometimes in math, we're going to say, I want you to know exactly what the answer is. And really essentially what we're wanting to do is to simplify. It means to make it easier, make it less cumbersome. So to get a perfect answer, we simplify the square root by using a factor tree. You guys remember what a factor tree is? This is like if you have the number, well, let's say 20. What two numbers multiply to make 20? Well, what about 2 times 10? Oh, and this one. What two numbers multiply to make 10? It's 2 times 5. And so we know 2 times 2 times 5 is 20. And these are all the prime numbers. So that's what a factor tree looks like. Okay, I just see a quick note. If you don't have a printer this week, that's no problem. What I would do is I would just get out a piece of paper. This will all be in the file so that you can watch it, look at it on the screen. When I get lower, as for instance, if I get to this page, you're just going to write a square root of 75, and you can show your work there so that at least you have it later. Or this, or these ones, you can just show your work. If it's just notes, you can just follow along with me, or write a couple quick notes like what's the square root of 30, and you can just draw this out on a piece of paper. Again, the notes aren't necessary. It's just really easy to follow through with me. And again, I'm sorry that I didn't send out the email with the files. Like I said, the files are always accessible through the Canvas course. You can just download the files and print them out ahead of time for next week. Okay, let's get rid of that square root of 20. So again, when you're simplifying radicals, the best thing to do is to use a factor tree. So again, here's the question: what is square root of 48 simplified? Well, I know that 6 times 6 is 36, and 7 times 7 is equal to 49, which is really close to 48, but it's not. So answer is going to be like 6.9, somewhere around there. But we want to have a perfect answer, like an exact answer, and we're simplifying this. So here's what we do to simplify the steps. Again, there'll be a question about this on the test. And again, when you're doing your test, please refer back to this example, and then maybe you'll remember and be able to work through the question in the test. So step 1, factor tree your number until it's prime. So we have 48. Well, I know it's even, so I can divide by 2. So 2 times 24, perfect. You can even in your calculator go 48 divided by 2 gives you 24. So 2 times 24 is 48. 2 is good, but I can still factor this into something smaller. So what multiplies to make 24? I can do a number of ways. You can go 2 and 12, you can go 3 and 8, you can go 4 and 6. All of them work. This is just how I'm doing it, but you want to keep going until all of them can't be divided by anything other than itself and 1. So again, 24, you could have 2 times 12 to get 24. 12, we can have 2 times 6. And 6, you can have 2 times 3. So we factored our tree until it's all prime. Step number 2, you're going to circle the ends of your tree. So circle all the ends. We're not going to circle 24 because it's split over again. The end of the splits, that's what we're doing. We're circling those. And again, this is just my technique, but it works. So I'm just showing you one technique that works. Then what we're going to do is we're going to rewrite the radical as the multiplication of the factors that we've just identified here in our factor tree. So the square root of 48 is 2 times 2 times 2 times 3 times 3. 2 times 2 times 2 times 2 times, oops, this is supposed to be a 2. That wasn't very clear. 1, 2, 3, 2, 4 2s and 1 3. 1, 2, 3, 4 2s and 1 3. Cool. So step 3 is done. And then the last one is step 4. I like to circle my doubles. I've showed you this in the last example, but this is really where they come in handy. So I'm going to circle my doubles. So I got 1 pair there, 1 pair there. So I'm going to pull this out, and it just becomes a 2. I'm going to pull this one out of the square root, and that becomes this 2. And this poor lonely 3, it's stuck in there. It doesn't have a pair. So you know what? Sad thing, but it has to stay in. Okay, and so we have 2 times 2, which is 4. And we still have our lonely square root of 3. And so what we do is we write this as 4 square root of 3. It really means 4 times the square root of 3. But because there'd be too many signs, eventually, like when you get into grade 10 or 11 math, 11 math especially, you're dealing with radicals, it just gets way too many to put times in, so we just leave it like this. It's the same as when we do 2x. This is like 2 times x, but we just leave that up. Anyways, 4 times the square root of 3, and that's the simplified version of square root of 48. All right. Hang in there, guys, because this is about as difficult as it gets here. Okay. Here's the practice part now. This is your guys' turn. So I'm gonna let you guys get a minute or two ahead, half a minute ahead. I'm gonna check my other screens, make sure I don't have anything waiting for me. And again, what you're gonna do is just follow those steps. Math is awesome because there's often really good rules, and as long as you follow them, like bed maths, you just follow that rule and you'll work through it and you'll get to the right answer. Same with these, there's a number of steps you follow, and if you follow these steps in order, then you'll come up with the right answer, and even better yet, you'll probably be able to check to make sure you got the right answer. Okay. 75, what 2 things multiply to make 75? Well, because it ends in a 5, I know I could have a 5 times something. So let's do that. 5 times, is it 15? And if you don't know what 5 times whatever, you go 75 divided by 5 in your calculator. You get, oh, 15, right, of course. Now, 5 can only be, the only 2 things that multiply to make 5 are 1 and 5. So it's prime, that's as far as it can go in that branch. But 15, I know that I can multiply 15, I can multiply 2 numbers to get 15. That's going to be 3 and 5. Cool. Now that I'm here, I'm going to do my step 2, which is I'm going to circle the ends of all my branches. Step 3, I'm going to rewrite these in here. So the square root of 75 is the same thing as saying like the square root of, and I'm just going to mix up these order a little bit just to make it a bit more easy for me. Square root of 75 is the same thing as the square root of 5 times 5 times 3. The next step, I'm going to circle my pairs. And then I can pull that out of the square root. If I pull a pair out, it just becomes one of those. And then I've still got a square root of 3. The 3 is, like, again, pretty lonely. Hopefully I save it next time. And so the answer is going to be 5 square root of 3, or 5 root 3. Okay. Again, I can help you guys out. If you're not understanding these, I can definitely help you out towards the end. I'm going to have a pile of time to just answer questions later on. All right, let's do question number B. What's this? We're just simplifying again. So what's the square root of 90? So I'm going to make a factor tree. So I'm going to say, what 2 numbers multiply to make 90? 9 times 10. You could do 2 times 45 and go that way. I'm just choosing 9 times 10. What 2 numbers multiply to make 9? Oh, 3 times 3. And what 2 numbers multiply to make 10? It's 2 times 5. And I think that's pretty much all prime. So I'm going to rewrite my square root as 3 times 3. Oops, that wasn't it. Times 3 times 2 times 5. And I'm going to circle my pair. Whatever pairs, these ones are all lonely, so they have to stay lonely. I'm going to pull that out. If I pull out a pair, it just becomes one of those numbers outside of the square root. And I'm still left with the square root of 2 times 5. I can just write this way. Or I can simplify that. That's 2 times 5, it's square root of 10. Or sorry, what's 2 times 5? It's 10. So I've got, my answer is going to be 3 square root of 10. Okay, you guys could like this one. So Again, I'm going to go through nice and quickly so that we have lots of time in the end. So I think we're halfway done already. Yikes. All right, so let's do 32 is 2 times 16, and 16 is going to be 2 times 8, and 8 is going to be 2 times 4, and 4 is going to be 2 times 2. I'm going to circle the ends of all of these, 3, 4, and 5 of them. So 2 times 2 times 2 times 2 times 2. I just want to make sure I'm staying on the page. Sometimes you'll also see in math, they just put this little dot, not like a dot like a decimal, but dot in the middle of the number, and that also means multiplied. What I'm going to do is I'm going to circle a pair, I'm going to circle another pair, and this last 2, it's stuck, it's lonely, it doesn't have a partner. So again, I'm going to pull this 2 out, I'm going to pull this 2 out. So when I pull this pair out, it just becomes a 2. When I pull this pair out, it just becomes a 2. And I've still got a square root of 2. He hasn't been able, he can't come out. He doesn't have a pair yet. 2 times 2 is 4, square root of 2. Again, if this is not quite making sense, I can do 100 of these at the end here. All right, I think that we deserve to change colors here. I just have to find a new color. All right, purple it is. Okay, so we have squares, and we figured out squares and square roots and simplifying and doing all kinds of crazy things with them. Let's talk about cubes. Cube is essentially a square with a third dimension. So a square is 2 dimensions. We're adding a third dimension here. And of course, a cube has all the same sides. So again, it's a square which has side and side that are same. And a cube also has the same depth. So it's like 2 times 2 times 2. So a cube is when you multiply a number by itself and then to multiply it again a third time. So for instance, 2 cubed, or 2 to the exponent 3, or 2 to the third, you can say any of the above, those all work. 2 cubed, or 2 to the third power, is 2 times 2 times 2. There's 3 times it's multiplied by itself. And if you do it, 2 times 2 is 4, and 4 times 2 is 8. Perfect. That makes sense. I'm just going to let one more person in here. Perfect. All right, so let's do 3 cubed, or 3 to the power of 3. 3 cubed means it's going to be 3 times 3 times 3 a third time. 1, 2, 3 times. Perfect. And 3 times 3 is 9, times 3 is 27. The other thing that you can do on your calculator, there should be a button like this, or something like that. It might be a Y. I don't know exactly. Again, all calculators are different. So if you hit 3 and then this button on your calculator, it should give you this answer. Again, this is a really good thing to figure out how to use your calculators. You don't often use this, but sometimes you will. But it's good to know what it means. Okay,
I got a question.
Cubed. Oh, you have a question? Please, yeah, go ahead.
It says I only have x2 on my calculator.
Oh, okay. Do you have a button that has an X to the Y?
Let's see. I have.
Sometimes it's in like another color, like it's in yellow or green, but it's like a second, like a shift or
The only things I have that are even close to that are the sin -1, cos -1, tan -1, and then EX, tan X2.
Okay. Let's figure that out. Can you hold on? We don't need the calculator for this right now, which is great. And maybe what I can do is let's talk shortly after this, and I can give you some options. Because again, the calculator that's on the computer does not have a cube button. And again, this is weird that it doesn't. You can probably download a great one that does. But we'll figure that out here in a few minutes.
Okay, thanks. I was just wondering because.
Yes, you know, and that's why, like when I talked last week, I was saying make sure that your button has a cube and a cubed root. That's really helpful. Some of these calculators don't have a cubed root, which is really helpful to figure out. It's almost impossible to do it without a calculator, the way that we're doing it. So yeah, let's talk afterwards. Definitely ask me that question again in the chat, or we can talk once this lesson is over. Thank you, great question. All right, so let's do 4 to the 3rd power of 4 cubed. This is like having a cube with sides 4 times 4 times 4, and it says, what's the volume? This is how you calculate volume of a cube. It's this times this times this, and it gives you the volume. So 4 cubed is like 4 times 4 times 4. And then you can just do it in your calculator. You can go 4 times 4 times 4 is equal to 4 times 4 is 16 times 4 is 64. And I'm going to make a fool of myself because I'm not exactly sure what 6 cubed is. I'm pretty sure I know, but 6 cubed. That's like saying 6 times 6 times 6. It's 3 times. 6 times 6 is 36 times 6 is 180, 190, 200, 210, 216. I hope that's right. Again, I'm going to prove to you that you can do this. 6 times 6 times 6. 216. Perfect. So again, it will work. The other way is harder, but I'm not going to make you do too many of those. So the same when we did squares and squares, or a number squared, and then we said, okay, the opposite is a square root. The opposite of a cube is a cube root. Looks like the same radical sign here, but you need to put in that 3, or else we're going to assume it's a square root. If you put in a cube root, oops, I didn't mean to draw on that. It means we're asking what number multiplied by itself 3 times is equal to 27. It's like, okay, we can do this. Yeah, again, I just put that in. Let's factor tree this. So factor tree the 27. 27 is like 3 times 9, and 9 is 3 times 3. Let's circle all the ends of our tree and rewrite this. Cube root of 3 times 3 times 3. This time we're looking for triplets. Last one we were doing squares, we were looking for pairs because it's square or 2. Here the number is 3, so like the cube root. So we're looking for triplets. And as we're going to circle a triplet in there and pull it out, it becomes just one of these again, which is 3. Okay, I'm going to do an example at the bottom, then we're going to zoom on. So my example is 125. Well, I know I can divide that by 5 because it ends in a 5. So 5 times what? Oh my gosh. Is it 25? Again, if you don't know, 125 divided by 5 in your calculator, oh, it's 25. And I know that 25 can go 5 times 5. Sorry, I'm making a mess of this. I'm going to circle these, try to save this problem. So it's a cube root. I have to write my 3 in there. It's 5 times 5 times 5. Now I'm going to circle a triplet because, of course, I'm dealing with cubes. 3. As I pull that triplet up, it just becomes one of those numbers. And there we go. We're done. And I just put in one of these just because you might run into one of these at some point. You can also simplify cubic roots. So again, I want to try to simplify the cube root of 32. Same rules apply. I want to do a factor tree, so I make this 4 times 8, this is 2 times 2, and this is 2 times 4, and this is 2 times 2. I'm going to circle all the ends of them, and I'm going to rewrite it back in my cubic root. So cubic root of 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5. Yep. Then I'm going to circle, instead of my pairs, I'm going to circle my triplets because it's a cubic root, and I'm going to pull that out. Essentially what I'm doing is I'm just separating them, but I'm going to pull that out, and it's going to become just one of those. And these two are lonely. They don't have triplet, so they can't come out. They have to stay in. And the cubic root of 4, so it's going to be the 2 times the cubic root of 4. We're going to do one more example, and then we're going to move on to the good stuff, which is Pythagoras, and it has a million cool examples. So 54, can I do 9? 9 times 6. And 9 is 3 times 3. And 6 is 3 times 2. So I'm going to write my cubic root. It's going to be 3 times 3 times 3 times 2. I'm going to circle my triplet. And I'll be able to pull that out of the cubic root. It just becomes one of those triplets. But I still can't do anything. I can't simplify the cubic root of 2. So the answer is going to be 3 times the cubic root of 2. Again, I'm going to leave this for now. If you have other questions later on, please ask me when we're done, and I can come back to these and we can go over 100 different times just to make sure that you understand it. But I do want to leave lots of time for these last 2 pages, and this is about Pythagoras. Now, I feel terrible because Pythagoras deserves a nice big title and it should be colored and all the rest, but it isn't. And Pythagoras is really awesome. You're going to run into Pythagoras quite a bit this year, next year, even in grade 10. So we might as well learn these. So Pythagoras was a guy who lived at about 500 BC, ages and ages ago. He's this cool guy with a beard. He figured out that if you take a right-angled triangle, so a right-angled triangle is one that has a 90 degrees here. This corner has to be 90 degrees. So if you take a right-angled triangle and make each side a square, so if I took this, which obviously is 3, and I made it a 3 by 3 square, a 3 by 3 square, I took this side, which is 2, and I made this a 2 by 2 square. This would be the exact, if I took this piece and this piece, and I cut them up, I could fit them exactly into this square, which is going to be a certain amount. It's really cool. There's tons of applications for this because how many times are we going to have to cut up a piece of paper to figure out how it goes in? And I'm going to show you what the applications are. There's literally a million applications for this, and it's not that hard to learn. So what we're going to do is we're going to just take a triangle, and it's got to be a 90-degree triangle. It's really important that we know that. In Pythagoras, there's always a 90-degree corner. If you draw an arrow from the corner through the little box and directly across, you're going to run into what we call side C. It's also called the hypotenuse, but I figured I wasn't going to confuse you guys. Always make sure that the side across from the 90-degree box is C. And then what we're going to do is we're going to rename the 2 other sides. But this is a really important step. If you miss this step, then you probably won't get the right answer. So the formula for Pythagoras, or Pythagorean theorem, is c squared equals a squared plus b squared. Or you could do a squared plus b squared equals c squared. Either way, it's totally fine. The important thing is that c has to be the diagonal, the one straight across the right angle triangle. So step 1 is to label the sides. Let's figure out which is side C, and then which is side A, and which is side B. So we've already talked about this, really important. This is going to be C for sure. And it's going to be the longest of the 3 sides. This diagonal is always the longest. Side A and side B, it doesn't matter. You can call this A and B. You can call this B and this A. It doesn't matter. But we need to we put a label on it just so that we know what we're talking about. But C definitely does matter. It's really important to get C right. Step 2, you're going to write out the formula. C squared equals A squared plus B squared. And now the step 3 is I'm going to fill in my variables that I know. Well, I know that A is equal to 3. So instead of A here, I'm going to put in 3. And B here is going to be 4. So I'm going to replace B the letter B with the number 4. Cool, now I'm starting to get some numbers that I think I know what to do with. 3 squared, that means it's 3 times 3, right? We talked about that in page 1. 3 times 3 is 9, so I'm going to just replace 3 squared with 9. I'm going to simplify it again. And 4 squared is like 4 times 4, which is 16. I'm going to simplify these too. I can combine these, it's no problem. 9 plus 16 is 25. And so far, C squared is just sitting in the back, feet up on the desk, hands behind its back, going, all right, this is awesome. Essentially, this is the only time we really need to do anything with C. We've done step 4, we've done step 5. We want to know what 1C is, not what a C squared is. So what we're going to do is we're going to take the square root. But if we take the square root of this side, we have to take the square root of it, the other side. And I'll talk about this in about 2 more lessons in great detail. But essentially, you're going to take the square root of both of the sides. The square root of C squared is just C. And the square root of 25 is 5 times 5. The square root of 5 times 5, which is 5. So we know that this side is going to be 5 long. And again, it has to be longer than this one and this one. I'm going to let that sink in for about 30 seconds. And we're going to move on to the next page, which I think is the last page that we're going to do as the lesson, which is great. We're almost going to be on time. Not quite, but all right. Here we go. And the drawings are going to come here too. So cool. So here we go. This is our example. We have a triangle, and it's a right angle triangle, which is good because this is what we need. And it has one side of 5 and one side of 12. We just don't know what this sloped side is. So let's identify side C and then label A and B too. So side C is, of course, if you draw a line straight through, shoot an arrow straight through that right angle triangle. This is going to be C. This can be A and B. This can be B, and this can be A. It doesn't really matter. I'm just going to label this just because it's easy. Okay, so I've done that. Check. I'm going to write out the formula. Do you guys remember what the formula is? Just whisper it to your own ears. A squared plus B squared. Okay, I'm going to replace my known numbers. Well, I can replace A with 5. I don't know what C squared is. That's what eventually that's what I want to do. It isn't A plus B equals C. It has to be C squared equals A squared plus B squared. Because, and I'm going to show you this. In this one, 5 does not equal 3 plus 4. 3 plus 4 is 7, which is not 5. So you need to definitely have a square. If you don't have a squared button, it's no problem. You can do this in the calculator on your own. And I'll show you exactly how to do that. So I'm just going to replace A with 5. So A is going to be 5. And B is going to be 12. All right. It's going to be a bigger one. That's fine. Now I'm going to crunch my numbers. That's what I sort of say in the calculator. Or you can do it in your head. But I'm just going to calculate this. This is going to be like 5 times 5, which is going to be 25. And this is going to be 12 times 12. And you can do that. In your calculator, you can go 5 multiplied by 5, and it gives you 25. And you can go 12 times 12, and it's going to give 144. I'm just going to do it because I'm running out of space here. I'm just going to do 25. And in my calculator, I went 12 times 12, and it gives me 144. Cool, now I can combine these numbers. 25 and 144 is 169. And this is where a calculator would be really helpful. You can take the square root of both of them. So this gives you C is equal to, and the square root of 169 is 13, because 13 times 13 is 169. So this side is going to be 13 long. Is this longer than this one or this one? Yes, it is. Okay. Let's go to the next one. There's a couple more that I want to cover over. Now, in this example, sometimes they're not always nice whole numbers. And this is where you're going to use a calculator because this is going to make more sense to you. Let's do this one. And this side is 4 and this side is 4. We don't know what this side is. First thing we're going to do is make sure there's a 90-degree angle in this. This is a 90-degree corner, so it's a right angle triangle. Perfect. This is what we're using. So we're going to draw an arrow right through. And it hits the side, which we're going to call C. Doesn't matter about this one. Doesn't matter what we call that one. This can be A and B, and this can be B and A. It doesn't matter again. So I've labeled my sides. I'm going to write my formula in here. A squared plus B squared. I'm going to replace what I know. I know A is 4, so I'm going to replace that. I don't know what C is yet. And B is going to be 4. So I'm just going to replace the letters with the numbers that I know. I can simplify this. 4 squared is like 4 times 4. So in your calculator, you can go 4 times 4, which we know is 16, plus, and 4 times 4 is 16. We're going to combine these. So C squared is equal to 32. And here's where it's going to get a bit trickier. We're going to take the square root of both sides. So C is equal to what? And I'm going to definitely need my calculator for this, because I don't know my multiplications that well. 32, I'm going to take the square root right here. 5.666. Why not that? 5.66. So this is going to be 5.6. Oops, that was not a very good letter. 5.6 or 5.7, whatever you like. Sometimes I'm going to say, oh, just show me to the closest decimal, and then you just go 5.7. Or you can put a few numbers like this. This is all correct. I'm going to give you the benefit of the doubt. If you got this far, then you know what you're doing. 5.7 should be the longest of the 3 sides, which it is. That's great. And so we can move on. All right, I really like this example, not necessarily because of the example, but because of the superpower. So currently I have to walk, I start here, I have to walk 5. To get to the grocery, I have to walk 5 blocks this way and 2 blocks this way to get to the grocery store. If I had the superpower to fly there directly, which would be fun, how far would it be? Maybe if I don't have the superpower. If I have a drone that's able to lift me up and drop me in the parking lot, how far would that be? So again, this is one of these, a pretty easy example, but again, I want to figure out what the distance is right here. I don't know that I can, oh yeah, right, I can do that. So again, this is going to be the square root, the 90 degrees. I'm going to label my sides. Shoot an arrow straight through to hit my side C. Definitely has to be C. Does it matter this is A or B? No. So I'm just going to label this A. And this could be B. I'm going to write out my formula here. So C squared equals A squared plus B squared. Okay, C squared is equal to, A is going to be 5, so I'm going to do 5 squared. And B is going to be 2, so I'm going to do 2 squared. Now I'm going to start crunching some of these numbers. This is going to be 25, because it's 5 times 5, right? 5 squared is 5 times 5, and 2 squared is 2 times 2, which is 4. C squared is equal to 29, so it's going to give me this weird decimal, but that's fine. I'm going to take the square root of both sides. So C, square root of C squared is just C. And so I'm going to use the calculator, which I have to find. Here we go. 29. And I'm going to get the square button. 5.4. All right, no problem. This is awesome. So I would have saved myself 1.6 blocks of walking. Actually, I'd have saved myself a lot more because I'd have just been flying. But it's what I want to do is I want to make sure that this number is the longest out of all 3 sides, which it is. And so I'm guessing if I get something like 50, I know that I've done something wrong. It can't be 50. And it can't be 0.5 either because it's way longer than that. If this is 5, then this has got to be a little bit longer. So again, you can get some guesses to make sure that you're right. All right, 2 more, you guys. Hanging in there. We're almost on time and everything. Oh, you know what I'm going to do? I'm just going to, let me just, oh, I don't even know how to do this. Sorry, you guys. I'm just going to do this for a second. I'm just going to erase it because I don't want to. I want to work it out. You can tell me. You can work through this with me. All right, here we go. So here my cat got stuck in a tree. Poor little cat. Looks sad. I have a 20-foot ladder that I place 4 feet from the base of the tree. How high does my ladder reach up the tree? So the 20 feet is diagonal. I just don't know how far straight up it reaches. And so this is one of these ones where we're given the C, and we need to find one of the other ones. And there's a little trick with this, but they're pretty darn similar in terms of how you do these. So again, what I did was, oops, I need to get some color here. Excuse me just a moment. No, I don't even know how to do it. There we go. Guess I'm changing my colors again. For the example, I wanted to redraw this just to show you that it's not necessarily a tree, but this is the triangle that we've been dealing with. It's a right angle triangle. So this is going to be 20, and this is going to be 4, and this we don't know. So again, the same sort of deal. We're going to draw an arrow straight through to find our side C. We can label this A and B. We can label this B and A. It doesn't matter. I'm just going to do A, and I'm going to do B. Now that we've got our sides labeled, I'm going to write my formula. So C squared equals A squared plus B squared. I can race through this because you guys already have all this writing down. Here, we're going to replace C with 20. So it's going to be slightly different here. But that's no problem. A, we don't know. So I'm going to leave it as A. And B is going to be 4 squared. It says crunch our numbers. 20 times 20, or 20 squared, is 400. A squared, we don't know. And 4 squared is 4 times 4, which is 16. And here we go. We're going to just jump ahead 2 chapters. What we want to do is when we've got A, the variable all by itself. So I'm going to subtract 16 from this side, but if I do it to one side, I have to subtract 16 from the other. That's the only difference that these questions are. So this could be 384. Is it really 384? Okay. And I'm going to take the square root of both sides. Doesn't matter what side the variable is. A is equal to, and let's figure out what is 384. Please holler if I'm not getting the right answer. It would be terribly embarrassing. 19.6 is it? Yeah, that's right. So it reaches up 19.6 feet, hopefully enough to get my cat. Okay, we're going to do one very similar to that. It's your turn. It's too muddy that close to the tree, so there's a big mud puddle here. So now you have to place the ladder 8 feet away, and it's not going to reach as high. So how far does my ladder reach? So I'm going to draw my triangle again. There's my tree. It's going to reach out farther. And my ladder is still 20 feet long. This one, it's going to be 8 feet out, and I don't know how far it reaches up. And here's my cat. Okay, enough drawing. So let's, here's my 9 degrees. Let's do the same thing as we are always doing. You draw my arrow straight through the 90-degree corner, and it leads me to side C. This could be my A, just for no other reason than I can't decide whether it's A or B. And B is going to be 8. So I'm going to write out my formula. C squared equals A squared plus B squared. I'm just going to replace my variables with known numbers. So 20 is my C. A, I still don't know. That's fine. And B is going to be 8, so I'm going to write my 8 squared there. So again, 20 squared is 20 times 20, which is 400. A squared, we still don't know. 8 squared is like 8 times 8, which is 64. And here's the only trick to it. We're going to subtract 64 to get rid of it on this side. 64 minus 64 is 0, so it just disappears from that side. But if we do it to that side, we have to also do it to this side. This is going to be 326. No, that's not right. 336 equals A squared. These ones cancel out, or 0, so that's fine. Take the square root of both sides. And we just have to figure out what the square root of 336 is. $18.3. So now it only reaches up 18.3. Hopefully I can still save my cat. But from here to here, this is 18.3. I hope this is making sense to everyone. Now, what do I want to do? I'm going to show you guys here really quickly the test. We all know that the test can be found. Let me just go back here for a moment. Still remembers me, doesn't it? The Pythagoras test. Oh, okay. That's just going to drive me crazy. Anyways, it's on the website if you need to find the test. It's also in the email I sent late last night at about 10 o'clock. And so this is it. Find the following squares and cubes. Just remember, there's a cube here. These are all squares. And we're looking for numbers that multiply to make those. So again, go to page 1 and look at how you did them. You should be able to get those, ace those. Question number 2, without using a calculator, it sure looks like without a calculator. So here's the example. Here's your thing, your question. Find the value of the square root of 13 to 1 decimal place. That's fine. Question number 3, simplify the square root. Simplified. We did a bunch of that. That was like 40 minutes ago or so. And leave in radical form. Radical form means that there's going to be a whole number and there's going to be a square root number multiplied by each other. Simplify the square root. That sure looks like it's going to be, let me see, simplifying radicals, just like on page 3 at the top there. So you can do that. Follow those notes. If you want to use your notes to write this test, awesome. My goal is so that you understand how to do these. It's not how fast you can memorize it. Again, simplifying the cube root and leave in radical form. That's also on page 3. There's an example here. I think simplify the cubic roots. If I didn't write all over my letters, this is the kind of question that I want from that one. And then the last page, of course, there's going to be 2 of these. Find the missing side. Now again, don't be mixed up. Sometimes I'm going to twist around the triangle, but all the rules apply. Same rules apply. And question number 6, you get to go ziplining, which would be really fun. Again, for those people who are going to say, oh, I'm just going to zip line right into the ground and I'm going to get squished like a bug. Yes, you would, but this is my example. Terrible example, but again, read really carefully. 100-meter long zip line is hung in the trees. The landing spot is 97 meters away from the base. So figure out which side I'm talking about. Put those numbers in there, label it, calculate it, and I bet you'll come up with the right answer. And also just check to make sure that the hypotenuse, or the side C, is the longest out of the 3 sides. Those will all be really good indications. Awesome.